Okay, so this is going to be a tutorial, sort of, and also going to look through the features that I've created. I'm going to have to learn these shapes. Now, I'm not sure if I'm going to find the source code. I'm still sifting through it. I only found like the surface stuff and not the actual stuff. The super epsiloid is something that I was recommended to learn by Voxel Quest creator. He also was capable of stretching super epsiloids, I suppose, and doing other stuff. So there's just so much to learn. I cannot even do a simple ellipse. I'm barely gonna introduce you guys to how I do a sphere. Barely. I had to learn how to do it efficiently enough to where it makes sense to me. Beforehand, I was using a code from other sources, basically. I can show you how it looked like. This chunk versus this. Slightly more efficient, and again, I understand everything that's going on over here, and I have no idea what the fuck is going on over here, and I hope I don't have to use these terms like a discriminant. I know what a discriminant is. I have learned it in my high school, and it's a way to sort of have a function, and that function has two solutions to it. You find out what those solutions are because they're sort of what's the right word? You know, you have this, god damn it, you have this minus thing plus the same thing but a plus, like a mirror thing. God damn it. Anyway, so I think there's a lot more calculations here, even though there's one article that I've learned from saying that, oh, we're gonna make a few optimizations and shit. Where is this minimal ray tracer? So I think that's the one. That's the wrong page. This is the picture and the description that I've took and learned everything basically. And this is some big stuff to learn, actually. I reminded myself that dots simply means taking any point in space and projecting it on a line. That's very simple. So you can take a center of the sphere and project it on the line right here. You can get this position. And all you need to do next is, because you have this projection, you can actually get a distance there. Now, this is what the dot looks like. Simple, right? You get the position, as I said. Now you get this d length. So in order to get the length, you simply have this point, this point. You know how to take length of that. So that's what I do next. Then you have the sphere size. Make sure that the distance is not over the sphere size. Simple. That means that you're in fact hitting a sphere at this point. And this has to be lower. That means that you're traveling forward, not backwards. Only if you're traveling forward you can actually hit the sphere properly. And if the sphere was behind me, I would still sort of be able to hit it if I would not use this little check. And then you have simple function you can probably recognize this as a Pythagorean theorem to get from this length and the radius here, you get this length because of the right triangle, right? So you have the hypotenuse, you take this side away and you are left with this little leftover. It's kind of like an anti-dot, whatever that is. Can you actually do that? Because you can in fact dot a vector like this L vector. You can dot it and get the same point in space actually. So you basically taking this point and you dot this line on here, and you literally get the same effect as a Pythagorean theorem does. Does the same thing. So maybe that there's something about this interesting. And then you get these points. The way you get these points, because you get this distance and you need this distance, so you take this point, you figure out where this point is, you're gonna go backwards and forward using this distance that you just found using Pythagorean. And that's it. These are the points on a sphere, if you're capable of cutting sphere basically, because that's somewhat what you're doing, even though you can imagine this in 3D space and it works in 3D space as well. That's how simple this whole formula looks like. But with any other shape, I have no idea if this is gonna work out any similar way, or am I gonna have to use some kind of weird equations for this? Like, I have no idea. I have seen some crazy things and I'm scared. That's what it is right now. So hopefully that clears things up if anyone wanted to learn how these things are done. Now, another interesting thing are textures. Besides just having some weird isometric surfaces, I'm not exactly sure what accuracy means. It's a very big deal, right? Because it could mean that your ray travels, the moment you hit a surface, your ray starts traveling slower and somehow connects with other rays. Weird. It's like weird stuff. And then I'll have to figure out how they've managed to do this. This is like a program from started 1999, let's say from 2000, and it's still copyrighted at 2016. It's a really old program exploring ray tracing. It's already not as advanced as my stuff, because my stuff runs on GPU and that's it. That's the whole advanced thing. Like, it took me so long to just run that one scene, as you've seen, when I was like 3-4 seconds. So, but again, what attracted me to this specific program is the geometry that was generated over such a long period of time. How do you even do text with this? Like, what? Seriously? You can do textures with this popping out? It's pretty cool stuff. And I'm just at step 1 and I can barely scratch my head around this. Like, holy crap. So there's also some textures. So can I find it? God damn it. So I was researching, right? I took these texture to take a closer look at the Minecraft textures, and I wanted to make sure that I can create infinite textures, basically, that scale infinitely, that you can just easily configure and create another texture that way. So I'm so far working on these two simple textures that can be created out of some simple noise effects. And it's going to take a long time to master these two again. These are very complicated tasks at this point. And in a way, I'm sort of glad that they're there. It's pretty interesting, actually. It's pretty interesting to learn these new crazy things. So I'm gonna run my program. You have this texture right here. This is actually a 3D texture. So if I apply this to a sphere, you can see it cuts through a lot of things, and on the edge, it doesn't change at all. It's literally cutting through the texture because it's 3D. As I've said before, that's what I wanted to do. And these textures are infinite. They infinitely generated through noise. That's how cool they are. That's why I want them so badly. You don't have to draw them, you just code them into the game. And they can create some crazy effects as well. Yeah, that's the sphere. It works. It doesn't work when you are inside the box though. Something wrong with that. It works in lower resolution, so there's some weird stuff with that. But anyways, I also wanted to show you guys that, yeah, I can actually change micro blocks one block at a time, one block for a size. So it can be 8 by 8, or it can be 6 by 6, 7, or any number, literally. I'm just incrementing it by 1 each time right here. It also has a effect here when I try to create a sphere for a microblock or a microblock sphere. You can increase the detail really quickly and decrease it. So I think this is like 38 maximum at the moment displayed. I can also add microblocks inside microblocks and see what happens. Should be pretty interesting if I decide to do that, if I see it necessary. As I've said, you can achieve some pretty interesting detail just by microblocking together into different layers. Again, lower resolution in this case. Into higher is just spheres of Game of Life that I can update this fast. I can add a block and update it as well. Yay. Anyways, so that's, I think, all I wanted to show. There's some interesting stuff with the textures again. What I'm gonna be learning, like the hexagonal texture, the checkerboard texture, is fairly simple. But again, they don't include sources, which is like so painful for me. It's so painful because how am I gonna learn all this stuff? Also, this, you cannot actually have a hexagonal ball shape if you know how a hexagonal pattern works. So it's a little bit uneven, to say the least. So you have all these different patterns, the break pattern, everything I'll have to learn. Like this width pattern, pretty cool, right? It seems like wood pattern. It just says cylindrical, but that's so cool. Yeah, I've seen it used once as wood on an egg. You have this so-called leopard, quilted for wool text. Like, this is nice. This is some nice stuff right there. Another wood one. That's what I want to learn. Also, I found it very, very nice when I saw this. This is, you can ray trace through this shape, this set shape, and you get this sort of a texture created out of a shape. Like, so weird. Now, you can't actually ray trace through it, now I realize. You have to actually end up inside that shape once you reach the actual surface. You have to be inside this object. So, but it's still very, very simple application of how I can create weird looking textures. Like this was really fun to look at. You create this shape and you have this pattern, you create a top pattern, you can quickly start texturing this little shape right here. So cool. So cool, and goddamn it's gonna be difficult, but that's what the future holds. I'm just really glad that people have explored ray tracing a little bit further than I thought I did. Again, the only recommendation that I got is to look into super epsiloids, which are these shapes. But this is like level 5. I barely scratched the second level. The first level is like hitting a plane. And all my ray tracing program was doing is hitting one plane after the other. Like, that was a challenge to do. God damn it, this is crazy, right? At some point I was just gonna be like, it's just gonna move on. I'm not sure which level that is gonna reach, so. But that's something to look at, so thank you guys for watching.